Hi, I'm Dr. K and welcome to ChemSimplified. In this video, we'll apply the definition of homolog and isomer to differentiate if a given pair of compounds are homolog, isomer, same compound, or none of those three. We'll use an easy-to-follow flowchart that will help us to classify these compounds easily. I've posted a video on the introduction of homolog and isomer. Do check it out if you haven't done so. Here's just a quick recap on what is homolog and what is isomer. So as promised, here's an easy to follow flowchart that will help classify a pair of compounds as homolog, isomer, same compound, or none of those three. So we start by asking a series of questions that will lead us to the correct classification. So let's start by asking the first question. Do they have the same chemical formula? Meaning, do they have the same number of atoms for each type of element? If yes, then the next question that we need to ask is, do they have the same structure? Meaning, are those atoms all connected in the same way? If yes, then we have the same compound. If no, then we have a pair of isomer. So let's go back to the first question that we asked. If the two structures do not have the same chemical formula, then we'll need to follow up with the next question, which is, do they have similar pattern that differ by CH2 unit or units? If yes, then they are homolog. If no, then it's none of those three. Doing okay so far? Well, that's the entire flowchart. Are you ready to test it out with some practice questions? Let's start with the first pair. We start by asking the first question, which is, do they have the same chemical formula? So let's start by counting the number of atoms for each element. So the one on the left hand side is C7H16O. So 7 carbon, 16 hydrogen, and 1 oxygen. If you need a refresher on counting atoms, I'll post a link to the top right of this video. And the compound on the right hand side, we also have 7 carbon, 16 hydrogen, and 1 oxygen. So they do have the same chemical formula. So we're going to answer yes. And now we need to ask the next question, which is, do they have the same structure? So we need to look at the two structures and analyze to see if they're connected in the same way. So it's up to you how you want to do this, but usually for me, I just find a focal point and then I try to compare and make sure that they are connected the same way. So if I'm looking at the two structures, I have two groups connected to my oxygen. On one side of the oxygen, I have 2 carbons, and that seems to be true for both my structures. On the other side of the oxygen, I have 3 carbon long, and then 2 CH3 groups connected to it, like that. And let's compare on the right hand side, the right hand carbon. The right side of that oxygen, I have 3 carbon, and then 2 CH3 connected to it. So what do you know? These two are actually the same. They have the same structure. They are connected in the same way. They have the same chemical formula. So the classification would be same compound. Doing okay? Let's try the second pair. Okay, so this is what we have. Again, we start by asking the same question, same chemical formula, and we calculate the number of atoms. The left compound, we have 7 carbon, 16 hydrogen, and 1 O. The one on the right hand side, same chemical formula. So we answer yes, and then the question we ask is, do they have the same structure? So now just by merely inspecting this, you can easily see that they do not have the same structure. Why? Because the compound on the left hand side is an ether. The compound on the right hand side is an alcohol. So there's no way an ether is an alcohol. So they do not have the same structure. And that's why our classification is isomer. Pretty easy, right? Now we move on to our third example. The same question, count the number of atoms, and we see that we do not have the same number of atoms. So same chemical formula? No. Next question, do they have similar patterns that differ by CH2? Okay, well, I don't know if you see this, but there is a trend. Like I've mentioned earlier, I try to find focal point. So in this case, I noticed that I have a functional group, which is OH, alcohol, on both sides, right? So if I were to count on the, let's start with the compound on the left hand side. my OH group is connected on the second carbon. And in that compound, I have 1, 2, 3, 4. 4 carbon, and OH is connected to the second carbon. Now moving on to the right hand side, I have the same thing. OH is connected on the second carbon. See, I have 1, 2, 3, 4, 5, 6. 6 carbon, OH connected on the second carbon. So do these two have similar patterns that differ by CH2 unit? Yes. In fact, they are different by 2 CH2 units. So they are homolog. Last example. Here we have two structures. Just by inspecting, we know that we have a ketone on the left hand side and an ether on the right hand side. So same first question that we asked. Do they have the same chemical formula? Turns out to be no. Do they have similar patterns that differ by CH2 units? No, they do not, because one is a ketone, one is an ether, so they do not have the similar pattern. So once they don't have the same pattern, it's neither one of those. It's not the same compound, it's not a homolog, it's not an isomer, it's neither one of these three. So that's the classification. So we're done going through how to use an easy flowchart to classify a given pair of compound as homolog, isomer, same compound, or none of these. As usual, if you enjoyed this video, do give it a thumbs up. If you find it helpful in helping you classify these compounds, do share it with your friends or anyone you think might benefit from it. Do subscribe, click on that bell icon, and you'll get notified on new weekly videos. For more info or practice questions, do head over to ChemSimplified.com. I'll post the blog link in the description box. Thanks for watching, and I'll see you in the next video.